ternary acids. Ternary oxyacids. These have oxygen in them. These have polyatomic ions. So this, again, aqueous solution, and the compound has hydrogen and an oxyanion. The names for these acids come from the name for the oxyanion. So what we do is if the oxyanion name, those are things like nitrate and nitrite, right? If the name of the oxyanion ends in ate, we change ate to ick and stick the name acid on there. If the oxyanion name ends in ite, we change ite to us and put the word acid. I guess that should be italicized too. And just like for the binary acids, the number of hydrogens is equal to the charge on the oxyanion. Nope, I didn't write it out there. Okay, so how do you remember that ate and ick go together and ite and us go together? With a silly sentence. So here's my silly sentence. There are others out there, but this is the one I use. Rick ate him. I hope he's not human. Rick ate him before he could bite us. No, right? What kind of a sentence is that? It's silly. The sillier, the better. Rick ate him before he could bite us. So this is how you remember which goes with which. There's the ick and ate. Those go together. Ite and us go together. So if the oxyanion ends in ate, Rick ate. I change the ate to ick. If it ends in ite, like sulfite, I'm going to change the ending to us. So let's do some examples. Name the following acids. Notice that all of these have AQ after them, and they all start with H. So what we're going to do, these are oxyacids. They've all got oxygen in them. We're going to isolate the oxyanion. So this is what the name comes from. So here again, we need to know the names of those polyatomic ions. What's the name of the ion? It's PO4. Phosphate. So this is the phosphate ion. We change ate to what? Ick. Rick ate him. What would a person eat that could bite us? I don't know. I should probably figure that out. A snake. There we go. People do eat snakes. I personally wouldn't. Okay, so if we took phosphate and just changed it to ick, we get phosphic. Phosphorus and sulfur are a little bit odd because they've got this UR-OR thing that just kind of seems to come and go randomly. The OR is going to come back, and it's going to be phosphoric acid. I don't know why. There's probably a reason. It could be because that's what we've always done, or that's what it was called before we made rules. I don't know. But again, that's another area. I'm not going to try to trick you on that. But just be aware that it does kind of come and go. Phosphoric acid. What's this one? What's the polyatomic ion, the oxyanion? Bromite. Yeah. Bromate is BrO3. This is bromite. And I change the ite to us, bite us, right? So this is us acid. There's no hydro prefix here. That's when there's just hydrogen in another element. No hydro prefix. How about this one? What's ClO4? Perchlorate. Because this is the hyper version of chlorate. Chlorate is ClO3. This is perchlorate, one more oxygen. So I change the ate to ick, and I get perchloric acid. Students often have a fair amount of trouble with nomenclature, writing formulas, writing names. We are not, as chemists, we are not trying to be difficult. We're trying to be consistent and as clear as possible. If you can come up with an easier to remember system of naming a gazillion different chemicals, we would love to hear from you. But this is what we have. Okay, so we're not trying to trick you. Question?
Yes, why not prefixing on the hydro?
Why not the hydro? Because this is a different group of acids. And so it's got a different way of naming. When you see hydro something acid, so there's an acid called chloric acid. Chloric. Ic comes from 8. This comes from chlorate ion. Well, chlorate ion is ClO3 with a -1 charge. The -1 charge tells us we need 1 hydrogen. So this is the formula for chloric acid. There's also an acid called hydrochloric acid. They are different acids. Their names have to be different. If we use the prefix hydro with these guys, then this one would be hydrochloric acid. But hydrochloric acid doesn't have any oxygen in it. The hydro tells us it's just hydrogen and chlorine. And so we look at chlorine. Periodic table tells us it has a -1 charge, so it needs 1 hydrogen. And hydrochloric acid is HCl, aqueous. So there's an illustration of why we need to have a difference. Otherwise, they'd have the same name. Any other questions? Oh, good, I didn't accidentally do one of my examples. Writing formulas. What does that look like? How would you pronounce that? It's per-iotic. It looks like periodic, right? Periodic acid. Does that mean it's only an acid sometimes? On alternate Tuesdays, periodically it's an acid. No, it's per-iotic. So we're going to do the opposite of what we did in the previous slide. So per-iodic, we're going to get rid of the ic and the acid, and we're going to change ic to what? 8. Ric 8, ic 8. So this comes from per-iodate. So hopefully you've memorized chlorate. Chlorate is ClO3 minus. Iodine and chlorine are sisters. They do things the same. Iodate is IO3 minus. What do I change to make per-iodate? 1 more oxygen. So per-iodate is IO4 with a -1 charge. How many hydrogens does it need? 1. The charge is -1, it needs 1 hydrogen. So to write the formula then, I've got HIO4 aqueous. That's per-iodic acid. Any questions? How about this one? Chlorous acid. Well, the us came from ite. So I'll get rid of that. I'm going backwards. That's from chlorite. Well, that was chlorate. Chlorite is the light version. ClO2. 1 less oxygen than the regular chlorate. The charge is -1. I need 1 hydrogen. HClO2 aqueous. Chlorous acid. About nitric acid. What polyatomic ion is in nitric acid? Nitrate. Nitrate. Nitrite is NO3 minus 1. Minus 1, 1 hydrogen. HNO3 aqueous. Any questions? No cheering? End of chapter. We can go home now.